A solution is a mixture formed by dissolving a solute in a solvent. For example, a sugar solution is prepared by dissolving sugar as a solute in water as a solvent. By dissolving varying amounts of sugar in a fixed volume of water, sugar solutions of different concentrations are obtained. The concentration of a solution refers to the quantity of solute in a given volume of solution, which is usually 1 decimeter cube of solution. The quantity of solute can be measured in grams or moles. Therefore, the concentration of a solution can be expressed in two ways. One, mass of solute in grams in 1 decimeter cube of solution. And number two, number of moles of solute in 1 decimeter cube of solution. The concentration expressed in mole per decimeter cube is called molarity or molar concentration. So the definition of molarity is the number of moles of solute present in 1 decimeter cube of solution. In an acidic solution, the concentration of hydrogen ions depends on the concentration or molarity of the acidic solution. An acid with a higher molarity will have a higher concentration of hydrogen ions and hence a lower pH value. In an alkali solution, the concentration of hydroxide ions depends on the concentration or molarity of the alkaline solution. By increasing the molarity of an alkaline solution, concentration of hydroxide ions increases and its pH value increases. Standard solution is a solution where its concentration is accurately known. A standard solution can be prepared using a volumetric flask. There are 4 steps to prepare standard solution. Step number 1. The molar mass of the solute is determined and the mass of the solute is calculated without the amount of the solute that has been calculated. Step 2. The solute is dissolved in a small amount of distilled water and the solute is stirred or swirled to dissolve the solid. Step number 3. The dissolved solute is transferred into a suitable volumetric flask. And step number 4. Water is added to the required volume, a stopper is put, and the solution in the volumetric flask is shaken well. A standard solution is ready. During dilution, the amount of dissolved solute is fixed. The amount of solvent or water is increased. As a result, the concentration of the solution will be decreased. Dilution formula M1V1 equal to M2V2. M1 is the molarity of the solution before water is added. V1 is the volume of the solution before water is added. M2, molarity of the solution after water is added. And V2 is the volume of the solution after water is added. Neutralization is the reaction of an acid and a base or alkali to form a salt and water. Neutralization in agriculture. Soil from different sources have different pH values. Solid can be acidic, neutral, or alkaline. Farmers add powdered lime or limestone to neutralize acidity in soil. The traditional way of adding ashes of burnt wood is also effective. These ashes contain the alkalis such as sodium hydroxide and potassium hydroxide. Farmers use a compost of rotting vegetables or leaves to treat basic salts. As the vegetable and leaves decompose, carbon dioxide is given out. This acidic gas dissolves in water to form carbonic acid, which can then neutralize the alkalis in basic soils. Neutralization in industry. Effluent from the electroplating industry contains acids such as sulfuric acid and must be treated before it is discharged into rivers and streams. The acids in the effluents are neutralized by adding lime. Power station burn coal to produce electricity. Coals contain sulfur, and burning sulfur in air produce sulfur dioxide, which is responsible for the formation of acid rain. When a mixture of coal and limestone is heated, the limestone decomposes to form lime. The lime neutralizes the acidic sulfur dioxide. Sulfuric acid plants use the contact process to produce sulfuric acid. Sulfur dioxide gas is produced from the combustion of sulfur or from the roasting of sulfide ores. To prevent sulfur dioxide gas from escaping into the atmosphere, waste gases are scrubbed by passing through powdered lime. Lime neutralizes the acidic sulfur dioxide. Neutralization in medicine. Indigestion is caused by excess acid secreted by the stomach. It can be treated by neutralizing the excess acid. Anti-acid indigestion medicine contain bases like calcium carbonate, sodium hydrogen carbonate, aluminum hydroxide, and magnesium hydroxide to neutralize the hydrochloric acid in the stomach. What is acid-base titration? Titration is a very useful laboratory technique in which one solution is used to analyze another solution. One of the solutions is a standard solution of known concentration and is delivered from a burette. The technique involves determining accurately the volume of the standard solution needed to react exactly with a known volume of another solution contained in a conical flask in a reaction for which the equation stoichiometry is known. The completion of the reaction occurs when enough standard solution is added from the burette to react exactly with the other solution in the conical flask. To detect the completion of the reaction, an indicator is used. The point at which the indicator changes color is called the end point. The end point is the point in the titration at which the indicator changes color. The common acid-base indicators are litmus solution. The color in acidic solution is red, the color in neutral solution is purple, and the color in alkaline solution is blue. Methyl orange. The color in acidic solution is red, the color in neutral solution is orange, and the color in alkaline solution is yellow. Phenolphthalein. The color in acidic solution colorless, the color in neutral solution colorless, and the color in alkaline solution is pink. And the last one, universal indicator solution. The color in acidic solution may be red or orange or yellow. The color in neutral solution is green, and the color in alkaline solution is purple. The end point can also be determined by using a pH meter and a conductivity cell.